This is a video to accompany the sample exam for chapters 1, 2, and 3 for Statistics 252. As with all the exams, there are no calculators allowed, no notes, and these are closed book tests. If that seems strange to you, you can just maybe look at some of the requirements at other universities. For example, at MIT, in higher level math classes even, there's no calculators allowed. Fairbanks, same way. I'm not interested in some big old numbers and calculations. The most important thing is that you understand and can set up the problems. If you end up with some fractions you can't reduce easily, I'm expecting that you will leave them as fractions. Don't spend time trying to divide something out by long division that's taking, 5 or 6 lines to do it. That's not the idea. Okay, and there is a reference section pertinent to whatever the questions are in the homework, and what I've included in the reference section for 1, 2, and 3 is your bell-shaped curve and has the information on it, and if you've studied the bell-shaped curve then you're familiar with this and it's just a good review. Whoops, I thought I had the marker. The mean, which is denoted by the Greek lowercase mu, is right in the middle of the bell-shaped curve, and then what we're looking at is plus or minus 1 standard deviation, plus or minus 2 standard deviations, that's minus, this is plus, and for green, plus or minus 3 standard deviations. And now from the mean, which is right here, to the data value that's the mean minus 1 standard deviation, 34% of the data values lie in that region, and it's symmetric, of course, so 34% of the data values lie between the mean and the mean plus 1 standard deviation. So if you add those two together, of course, you get 68%. So all the way from here to here is 68%. But this whole graph is on part of the test, and it's right there, and you can refer to it. Because it doesn't help you if it's there if you don't know what mu means, what sigma means, have any idea what the bell-shaped curve is. So because you know all that, it's just a handy reference. The first set of questions on the sample exam, and essentially I'm doing the sample exam so you can read about it and you can follow along, and you can also listen to it on the video, so hopefully you'll have a good understanding of what's on the exam. The first part is on errors in statistics and misleading statistics. In the text and also in the lecture notes on Blackboard, there's a list of common ways that statistics are misleading. The first important one is that if you have an observational study or descriptive statistics, you cannot show causation. You can show correlation, but not causation. In particular, a retrospective study does not show causation because you're just looking at some data that somebody else took in the past, and there's no control over variables and no showing that you would not get that same result if the situation had been different. All you're showing is that result gave it to you. And that goes right down here with number 6, which is my favorite. Coincidence is not causality. Important thing to know. The second big problem with misleading statistics is that the sampling is not representative. There's a classic example of the Liberty Magazine poll showing one presidential candidate winning over the other, and it wasn't that way. The problem is they polled people who had phones and people who had cars, and in those days not many people had phones or cars, so you're looking at a very small subset of the population, and you weren't getting representative of all the voters. So the whole idea is representative sampling. And remember that convenience sampling, that's standing at the mall and asking people who happen to stop and agree to talk to you, or self-reporting, that sort of thing, convenient sampling is not representative. Another common problem with statistics is the misuse or inappropriate use of titles, names of institutions, Dr. So-and-so, Harvard Medical School. Did it really come from Harvard Medical School? who is Dr. So-and-so anyway, but by putting those in, it lends credibility to whatever they're reporting. So unless they have a reference for it, they're just name dropping. Another idea that misleads is this implied consent. Implied connections, not implied consent, that's something else. So implied connections and detached statistics. These are words like better than, it supports new digestive function, it's more significant than what, in that case, if it's just better, it supports, more significant, those imply connection, and they're detached statistics because there's no connection to anything. Then for graphs, clip art figures instead of dots or X's are often misleading because the height along the graph may change, but when the size changes as well, you get a magnification of the difference. Okay, so any graph with a clip art figure is probably misleading if that, especially if this clip art figure changes size. You don't have to list all those common errors. Instead, you have to point them out, and you'll be given some little reports. Here's a quote from the internet, copy and pasted. And I mentioned this before. The ancient Chinese believed that an eclipse was caused by a dragon swallowing the sun. If they knew an eclipse was coming, writes the BBC, the Chinese would shoot fireworks and bang gongs to scare it away. The return of the sun is proof that the dragon responded to the fireworks. What's the problem with this? It was coincidence, is not causality. It was coincidence, well, maybe a little bit more, because they stopped when the dragon moved, but that doesn't cause the dragon to move. I wonder what does cause the dragon to move, but that's a whole other issue. Okay. On B, it's describe the type, that's supposed to be the type, of sampling and discuss its merits. And here's the report. I collected data on study habits by interviewing students during my breaks from class. The students that stopped to talk to me were very cooperative. Well, how nice. This is convenient sampling. It is not representative. They're probably, just because it's convenient for you to interview people when you're on a break doesn't mean that gives you a representative sample of the people at your college. And here's an example. It does say to pick out in the real test. It says there are two, misleading statements that appear statistical. Identify them. And here's the statement. According to the National Institute of Health, taking vitamin C is not any better at getting rid of a cold. Well, right here we have the name dropping, trying to make this report more credible. No reference, just name dropping. And then a detached statistics is not any better. Any better than what? I don't know. So these are the two problems here. In this case, it was name dropping and implied consent or detached statistics. And now there's some variables where you need to, types of variables, and you need to give an example of them. I believe you also have to give a definition. Okay, what's a proxy variable? It's a variable that you measure in place of another, and you assume there's a good connection between the proxy variable and the one that you really want to measure but for some reason can't. Confounding variable, that's a variable that you do not control but has a great influence on the experiment. And I give an example here. If you're measuring the boiling temperature of various oils in different kitchens and you never took altitude into account, then the altitude would be the confounding variable. While you'd be controlling the type of oil and the temperature, the experiment, the boiling temperature will differ depending on altitude. Quantitative variable that is discrete. There's two basic types of variables that we measure. One's quantitative and the other's qualitative. The quantitative is further divided into discrete and continuous. A discrete quantitative variable is one that is counted. For example, the number of games that you win in a tournament. Okay, the number of cats in a litter. Those are counted, and that's a discrete variable because you can't have half of one. The continuous variables are measured. If you had the weights of premature babies in the NICU, that would be a continuous variable. On the test, you need to set up some stratified sampling. And you need to sample, in this case, 900 voters in a city. And in the city, the voters are divided among these interesting political parties. Scottish National Party, Sinn Féin, Plaid Cymru, the Ulster Unionists, and the Scottish Green Party. Okay, so you have the different representations. You have the number of people that are in each one of these political parties. This will be stratified sampling. What are the strata? The strata, or stratum, would be, the strata are the political parties. That's plural. Okay, so you're going to stratify along these political party lines. If you took 900 voters and got them all out of this party, you're not going to get representation. There's a table below. You have to calculate it, fill in the frequency. Is this easy to do without a calculator? Yes, because they all sum to the nice number of 100,000. So you'll fill in the table like this. You put your strata here, their names, okay? Then you put how many people, the count, how many people are in each party. Total that up, because you're going to need that total. In this case, it's 100,000. To get the frequency, you divide the 16,000 by 100,000. Now, if you've got problems with that, you might want to practice before the test. 16,000 divided by 100,000. Well, this is one case where you can do this. You cross off those zeros. I have 16 divided by 100. When I divide by 100, I move the decimal point 2 places to the left, so it's 0.16. So practice dividing by 100. These numbers might not be exactly the same, so it might not help to memorize them. So this is the next, So this is the calculation that you do, and it should add up to 1. Now you have to calculate the number of people interviewed. Oh, I did it for 800 here. I said 900, whatever. However many people you want to interview, you make that maximum and you multiply it by the frequency. Here I multiplied by 0.16, then by 0.26, 0.36, 0.12, and 0.10. In this case, there's no problem. Those are the numbers you're going to interview. And these had better total to 800 or 900, whichever. I changed these around a little bit for the sample exam from the real, so some number probably didn't get changed. Okay, if you have a fraction of a person to interview, obviously you're going to have to do some rounding because you can't interview 7/10 of a person. In this case, all these numbers were integers, so there was no problem. In this problem, you get to do a little bit of graphing, and you're given this much. So you need to sketch a frequency polygon. The frequency polygons are drawn by straight lines connecting dots at the midpoint of the classes. So right here, the midpoints calculated. So you need the midpoints. And you can do that by adding the extreme values of each class and dividing by 2, or you could denote that everything is has a class width of 5, and that would apply also to the midpoints. Then I give you graph paper. At each midpoint, you don't have to do the histogram, just at each midpoint you put the corresponding frequency in a dot, and then you connect up the dots by straight lines. Here's one of those box and whisker plots. You start off with a list of grades on a test. Alright, I don't know whether they're the maximum grades on a test, but they're the grades on a test. Find the median and the mode. To find the median and the mode, you write them in a list, from least to greatest or vice versa. The mode are the ones that are repeated the most often, in this case 55 and 60, because they're repeated twice. The others are only given once. The middle number, in this case, is 85. To find the quartiles, Q2 is also 85, and then you look at everything below 85 and find the midpoint of that, the median, which is the Q1, it's like the median for the lower part, and the upper half, you find the median here too. In this case, it would be 140. And now you just use that to draw a box and whisker plot. The hinges are going to be at Q1 and Q3. The vertical line in the middle of the box is at Q2, and the whiskers extend out to the maximum value, which was 165, and to the minimum value of 55. In this case, you're going to demonstrate that you're familiar with this kind of data. Say the resting heart rate in athletes was given as 62 plus or minus 4.8. What does the plus or minus 4.8 mean? The 62 is the mean, the arithmetic average of all the heart rates they measured. The 4.8 is the standard deviation. If you assume there's a bell-shaped curve distribution as in the reference section, you can calculate the minimum and maximum heart rates corresponding to where 86% of the recorded heart rates are about the mean. Right, so that's that center region. So to get that 68%, you go down one standard deviation, 62 minus 4.8 would be 57.2, and up one standard deviation to 66.8. So between 57.2 and 66.8, there were 68% of all the data points that were measured. All the heart rates went between, or lay between 57.2 and 66.8. And now you do the same thing looking for 95% about the mean. And 95% lies between the mean minus 2 standard deviations to the mean plus 2 standard deviations. And if you forget that, you can add those numbers up that are given on in the reference section. So when I subtract 2 standard deviations, I get a heart rate of 52.4. When I add the 2 standard deviations, I get a heart rate of 71.6. The real exam has something on temperatures in it, not on heart rate. So that's basically the sample exam, and you can work through it, be real familiar with it, because the actual test is very similar.